Hi, welcome back to STEM Storytime. My name is Taylor, and today we are going to be doing a couple of really fun things. We're going to be exploring ocean layers and liquid density. So this time around, I have a book called Down, Down, Down by Steve Jenkins. So I usually read the entire book, but this time I'm going to only read excerpts of it because the project we're going to do with it is a little bit more involved. There's more steps, and it just, for time's sake, I'm going to cut it down and just read parts of it. If you would like to read the rest of the book, you're in luck, because it's one of ours here at Greene County Public Library, so you can always just request the book and read it yourself. So, first off, we're going to start with I'm just going to explain what we're doing today. I've got lots of different materials over here because we are going to be making a representation of the ocean layers in a jar, a little mason jar, just like this. So I have a lot of different materials here, and I'm going to go through them here in just a second and explain what you'll need if you'd like to do it at home. So first of all, you'll need a jar like this or any other kind of tall glass object that you can see your different layers in. So I've got a 30-ounce mason jar. You will also need vegetable oil, Dawn dish soap, preferably Dawn, or it could be an off-brand, but the blue color is what we're looking for, so it'll match, the color of the ocean. Light corn syrup, just like this. Water, which I have here in my other jar, just regular water. And this is really big, but rubbing alcohol or isopropyl alcohol. Okay, you'll also need food coloring. Specifically, I have black food coloring, blue, and it says light blue as well, but or a dark blue. And I've got navy, and I also have teal, so I'm not sure which one I'm going to use yet. We're trying to get different shades of blue and dark colors so that we can show the different layers of the ocean. We'll also need, I've got 5 plastic cups back here. Those are for mixing our liquids with the food coloring. And then it says 5 plastic spoons. I just have a regular metal spoon that I'm going to be washing. I have a little plastic bowl over here with some soapy water in it. Additionally, I've got my tub for cleaning things, a towel, and a measuring cup. It says we're going to use 3/4. This is only a 1/4, so I'm going to use it 3 times. Okay, so let's get started. First, I'm going to just follow the instructions I have printed out right here, and we're going to start constructing our ocean layers. So the first step, we are going to measure 3/4 cup of corn syrup, which is right here, with our black food coloring right here. We're going to pour them into one of these cups, and then we're going to pour it into the mason jar. So away we go. This is stuck on there. Got paper towels, keep things as tidy as I can. All right. So it's so thick. There's about 1/4. And I may only do 1/2 cup because I don't think it's going to fill up the whole jar, but just to save on materials, I'm going to just do 1/2 cup. So I'm going to fill this up twice, which will be 1/2 cup of light corn syrup. Now it's super thick. See how it's all gloopy coming out of there? That's why I have my bowl over here to wash, because this can get pretty messy. All right, and now I'm going to add black food coloring. I'm gonna do a couple drops. 1, 2, 3. All right. You can see in there. Yeah, it's starting to mix already. Oh, it is so thick. It's all goopy and gelatinous. All right. So here in a minute, once we start reading the book, I'll explain why these colors are important. So it's not coming black off of the spoon, so I'm going to add a little bit more, just a couple more dots. Now this corn syrup is super thick, so it might take a while to get all of it to fall back into the jar, into our mason jar. All right. So there is our very first layer. So it's kind of, yep, looks black, dark corn syrup. Okay. Next, we are going to work on the second layer. I'm gonna have to wash my spoon here real quick, which we are using, actually, I can just wash this out. I'm gonna wash my little measuring cup a little bit. Try to get the corn syrup out as much as I can. All right, that's not too bad. And the next layer, you're going to use the Dawn dish soap. Corn syrup is so sticky. Okay. We're just going to pour in. Okay. There's one. Let's see what's happening here. And there's 2. I'm going to just do a little bit more. There we go. All right. So it might be a little hard to tell from here, but you can actually see there's a layer right here, and then there's the layer of dish soap on top of that. So it's starting to turn out pretty awesome. And if you look at it from the side, you can definitely see, if light is shining through it, you can see very distinct layers. So it's pretty cool. All right, so that's second layer. Then next, we're going to do water with dark blue food coloring. So I'm going to use navy blue, I think. Yes, I'm going to use the navy blue. Here's my jar of just regular water. I'm going to wash Measuring cup again. All right. Use one of these and just pour some water into my cup so we can mix it with the food coloring. All right. Now we'll add our navy food coloring. One, two. Wash my spoon off. Okay, let's stir up the water. Now, I don't know if this is going to be that distinct compared to our soapy layer, but we'll see what happens. All right, so we have our jar again with our layers, and now I'm going to add the water. Let's see what happens. So, oh my goodness, that's pretty cool. I know it's hard to tell from the computer, but it is actually forming into 3 layers. There's a layer here, and a layer down here. That's pretty cool. You can sort of see it. Color 1, color 2, and color 3. So it's starting to work. All right. Next is the oil, the vegetable oil. So this one doesn't say to mix any color in with it. I don't know if the color will mix with the vegetable oil. Actually, there we go. All right, so this just says to measure the oil and pour it into the mason jar. I think I'm gonna add a little color to it though, just to see if it'll work. It might not actually. It's possible that my color doesn't want to mix, but we're gonna give it a shot. I'm gonna mix a little teal in there and see what happens. That's right. I wondered if that would happen. The color does not mix with vegetable oil. It's not separating. It's not. Yeah, that's so funny. It turns into little dots. It just keeps its shape. It won't mix up in there. You can see little dots of food coloring. So there you go. So we're just gonna pour this in our jar. All right, so the layers are all frothy, and I think if we let it sit for a little bit, it'll start to go back to normal. So we'll work on our next layer, which is the last one. And this, we are going to be using rubbing alcohol. There we go. Okay. There's that. And we're going to mix our blue coloring to it. If I can open it. There we go. All right. Last layer. Starting to watch what happens. And our layers need to separate again. Color didn't really work out on that top layer, did it? So, the top layer is probably difficult to see, but it is in there. And if you look at it from the top, you can actually see that there's the bubbles of the vegetable oil are trapped down beneath the layer of alcohol that we just put on there. So we have 1, 2, 3, 4, 5 distinct layers in our jar. So that brings us to the book. All right. So I'll get back to explaining the jar in a minute, and hopefully by the time we're done reading, the jar will have settled a little bit better. Maybe some of the bubbles will go away. All right, so like I said, I'm only going to be reading some of this book. It's called Down, Down, Down by Steve Jenkins. All right. Starting here. Viewed from space, the Earth looks like a watery blue ball. Oceans cover more than 2/3 of the globe's surface, and well over half the planet lies beneath water more than a mile deep. We have explored only a small fraction of the oceans. In fact, more humans have walked on the moon than have visited the deepest spot in the sea. In this book, we'll descend from the ocean surface to the sea floor and travel through one of the most extreme environments on Earth. Along the way, we'll encounter some unusual creatures. All right. So, the topmost layer, the sunlit zone, or the sunlight layer. Near the surface, the water is warm and brightly lit by the sun. Light-loving plants, algae, and bacteria, most single-celled and too small to see with the naked eye, are found here in uncountable numbers. Almost all life in the sea depends on these microscopic organisms, which use the sun's energy to help them manufacture their own food. They themselves are food for billions of animals, including shrimp-like krill. Krill and other small organisms that drift along the ocean currents are called plankton. Mackerel and other fish gather in enormous schools to feed on plankton. So, skipping down, we're going to the next layer, the Twilight Zone. The Twilight Zone begins about 660 feet below the surface. From here on down, there is not enough light for plants to survive. Only animals live below this depth. To us, it appears completely dark, but many of the creatures here have eyes that are specially adapted to the faint light. The sunlit waters, with their rich variety of life, are just above us. Animals are rarely seen at the surface rise. Animals that are rarely seen at the surface rise from deeper waters to hunt in the Twilight Zone. So yeah, these are some crazy looking creatures. This says this is an oarfish, a nautilus, a goblin shark, and a snipe eel. So the next layer. We've reached the dark zone. Not even the faintest sunlight can reach us here. It's getting colder, and the pressure is enormous. Few submarines can dive this deep without being crushed. All around us, a delicate marine snow is falling. It's composed of dead plankton, fish scales, animal waste, and bits of larger creatures that have died in the waters above. These particles are the basis of life here. Small animals feed on marine snow and become prey for larger hunters. So the marine snow is what all of these little white specks are, if you can see them. Well, the light's glaring pretty bad, isn't it? This down here, that's called a pram bug. This is a pelican eel with this huge mouth, a deep sea jellyfish, and an arrow worm, really long and thin. We have arrived at a flat, nearly featureless surface. It's the abyssal plain. Sediment and marine snow has drifted down from above for millions of years, forming a layer of ooze that may be thousands of feet thick. Most animals here survive by sifting through the mud for bits of food. A few are predators or scavengers, eating other seafloor creatures and larger animals that die and sink to the bottom. Rocky outcrops here and there in the mud provide a habitat for the sea lily, an animal that looks like a plant, and other creatures that attach themselves to hard surfaces. Soon we'll continue our descent. We have a long way to go before we reach the deepest part of the ocean. So it's a little hard to see some of these, but right here, a swimming sea cucumber. These are those sea lilies. They do look like plants, don't they? A hagfish and a tripod fish. Now here we are at the very bottom. Here at the deepest spot in the sea, there is almost 7 miles of water above our heads. This is the Challenger Deep. Again, pretty hard to see because most of this book is black, isn't it? It is part of the Marianas Trench, a seafloor canyon in the western Pacific Ocean. Humans have visited this place only once. In 1960, the U.S. research vessel Trieste reached the seafloor with 2 scientists aboard. The descent took 5 hours, but the men stayed on the bottom for only 20 minutes. Unmanned probes have explored the Challenger Deep on a few other occasions, but it's still one of the most remote places on Earth. The pressure here is 1,100 times greater than at the surface, and the temperature is a constant 36 degrees Fahrenheit. Even here, life can be found. Shrimp, worms, flatfish, and thousands of kinds of bacteria live in the ooze or just above the muddy bottom. It's time to return to the surface. The trip will take 2 hours, and except for the lights we've brought along, we will be in complete darkness until the last 2 minutes or so. Just about every time humans venture into the deep ocean, they discover new and unexpected animals. Some scientists believe that we've seen fewer than half the large animals living in the sea. If we're lucky, we'll encounter some of these unknown creatures on our return trip. So on the very, very bottom, in the Marianas Trench and other trenches like it, you can still find shrimp, worms, and little flatfish. There's other things down there, but it's so remote, very few people have ever traveled there to see. So there is so much more cool stuff in this book, and lots of exciting charts at the back that actually show you how big things are compared to a human. So in that last section, the shrimp and the flatfish and stuff, they compare it to the average size human hand. So lots of really tiny stuff. Just above that, in the abyssal plain, they show other animals too. Mostly really small, but there are some big ones, and some of them are humongous. So, You might be wondering what any of this has to do with our jar. And I will say, no, the ocean is not made up of layers of isopropyl alcohol and cornstarch or corn syrup and things like that. The ocean is just made up of water. But we did this. I made this jar so that we could explain and have a visual representation of the different layers. So let's review those layers real quick, okay? So on the bottom, the very bottom down here, this black layer, this represents the trench layer, or the trench zone. The Marianas Trench would be one of them. So the deepest point of the Marianas Trench gets to 35,838 feet. That is the deepest point on the planet. It's so deep that you could put the Mount Everest inside the Marianas Trench and it still wouldn't break the top of the water. The next layer up, getting a little harder to see, but the next layer up, there is the soapy layer. Actually, pull it up to light. And it might have actually mixed with some of my water. Right around here was our soap layer. That is the abyss layer, and it reaches about 13,000 feet. It's also known as the abyssal plain because it is a long, flat expanse where lots of ooze, lots of mud and debris from things that have floated down over the centuries have laid flat and formed the surface, the bottom of the ocean. So as far down as 13,000 feet. The next layer, the midnight layer, right around in here, is 3,300 feet to 13,000 feet. So the midnight layer, there's no sun whatsoever. There's lots of crazy creatures down there, like oarfish and goblin sharks. And those creatures very rarely come to the surface. Some of them do, but only at nighttime. There's no sunlight down there whatsoever. But there is that marine snow that we saw in the picture. That is the basis of life down there. That's the food that creatures in the midnight layer, the midnight zone, will eat and feed off of. Just above that is the twilight layer, which is somewhere around here. It's our it was our vegetable oil layer. The twilight layer, there is a little bit of sun there, but it's so faint that you have to have special kind of eyes to see that light. It stretches from 660 feet down to 3,300 feet. And a lot of creatures will go stay down there during the daytime when the sunlight is out, and then they come up higher to hunt at night. Then the topmost layer is our layer right up here. That is the sunlight layer, which is from the surface of the water down to 660 feet. So it seems that my layers down here have kind of mixed a little bit, but there is a distinct, I can still sort of see a distinct change in here. But what do you think it is that makes these layers separate? When I pour them into the jar, why don't they all mix together? That is because of a property we call liquid density. So liquid density basically means everything is made up of matter. You and I are made up of matter. Liquids are made up of matter. This jar is made up of matter. Matter has different densities, meaning some are heavier and some are lighter. It's hard to imagine that different liquids have different weights, but they do, and we can see that here. Like solids, liquids are made up of different numbers of atoms and molecules, and in some liquids, these atoms and molecules are packed together more tightly, resulting in a denser or heavier liquid, like the corn syrup here at the bottom. These different liquids don't mix with one another because they're not the same density. This separation forms the layers in our jar. So, the atoms, the molecules in the corn syrup are packed a lot closer together, which is why they won't mix with the soap that's above it, or the water that's above that, or the vegetable oil, and then the topmost layer, which is the isopropyl alcohol. All 5 of them have different densities. Now, I think the reason that the liquid, my water and my soap mix together more is because they're a little bit closer together. And Dawn dish soap, things like this, are meant to mix with the water and get bubbly so that you can wash your dishes. So that was a lot of information. So let's just review it quickly. We learned about water density, which is why liquids don't always mix. And see, when I do this, when I move it, you can see how the bottom layer underneath, especially right here, you can see it won't mix with this top layer. It's so cool to watch. It's really cool if you can look at it up close. So I highly recommend making one of your own just to play around with it. So that's liquid density. And we did this so that we could explore the differences in the ocean layers. Those names again real quick. Starting from the top, we have the sunlight layer, the sunlight zone, the twilight layer, the midnight layer, the abyssal plain, and the trench. So that was a pretty cool experiment, one of my favorites. I love the ocean and I love studying it. So if you are interested in the ocean, in studying anything about water, ocean layers, the creatures in the ocean, this is a great book to check out. But also talk to your librarians and see if they have any recommendations, because I'm sure they have so many cool books they could show you. All right, thank you for joining me. We'll see you next time.